This is the quiz for second derivatives, extreme values, and limits and L'Hopital's rule. So go ahead, take a stab at these. Go as far as you can, and if you're unsure, just take a guess. And then pause the video at this point, because I'm going to start going on to the solutions. So go ahead, pause it, take a stab at it. Okay, now that you've tried it and you've gone as far as you can, let's check our answers. So the derivative of the original function up here, take the power, you get 7x6. Take the power down, it's 3 times 5. Over here, take the power down, it's 3 times 5. And then here, it's just 7. And then again, take the derivative of this again to get the second derivative. So it's going to be 7 times 6, 6 minus 1, 15 times 4, 4 minus 3, and then 15 times 2, 2 minus 1. Okay, and then the derivative for 1 over x, we're going to rewrite it like this. X to the negative 1 power. And then we're going to bring down the power. It's going to be negative 1 times x, and then the new power is going to be negative 1 minus 1. So that's our new value. And when we take the derivative of this to get the second derivative, we're going to bring down the negative 2 times negative 1, x to the negative 2 minus 1, so negative 3. When you combine these, you get 2x to the negative third power, or 2 over x to the third power. All right, so when we're talking about extreme values, we're going to take the original function and we're going to take the derivative. So the derivative of this is going to be this function. And then at that point, we're going to take this function and set it to equals 0. Wherever this function is equal to 0, we're going to figure out those x values. So we'll solve that, and it's going to give us x at 0 and x at 3. So those are going to be the x points that give us so let's call it here and here. Not this one. X at 0 and 3 are going to be our extreme values. And they're going to occur here and here. So what you're going to do with those values is you're going to plug them back in to the second derivative. And then it's going to tell you if it's a maximum or a minimum. So now that you have the derivative, take the second derivative, which is going to be equal to this. And then now they have a second derivative, plug in x is equal to 3. And then get these values, and you get 72. So since your second derivative is greater than 0, it's going to be a relative minimum right here. So that's a minimum. Now, we aren't doing x is equal to 0 because our interval is 2 to 4. And only 3 lies in that interval. So that's it. Okay. Let's take the derivative of these trig functions. No, this is the limits. Okay, so the limit of tangent x over x as x approaches 0, first plug in 0 to tangent x and to x. Now, tangent x is going to be equal to x over y. Think about it. At this point, what is the x value? 1. And what is the y value? 0. 1 over 0 is equal to some unknown value. So we can't use just tangent x over x. That's why we take the derivative. So take the derivative of tangent x and take the derivative of x, and you get secant squared x over 1. Now plug in x is equal to 0 for secant squared x. Okay. What we're doing is we're changing secant to 1 over cosine, because 1 over cosine, we can at least mentally understand cosine. Secant is a little bit harder. So let's ask ourselves, at cosine of 0, what is the value? Well, cosine is asking for x. So over here, our x value is going to be 1. So 1 over cosine squared at x is equal to 0 is going to give us 1. So this is going to be equal 1 squared. So 1 over 1 squared over 1 is equal to 1. Okay, and then let's take this next function and figure out where it approaches as x goes to infinity. So my tip is ignore everything here. Look at just the biggest x's. You have x to the 4th and then x squared. These are all smaller. You have x to the 4th and x squared. These are all smaller, so ignore these. Just pay attention to the biggest ones. So you're going to have 2x to the 4th over x to the 4th. Now, simplify this. You can cancel out these two, and you just get 2. Because infinity to the 4th power over infinity to the 4th power is the same thing. Infinity over infinity is 1. So you're just going to have 2. So this equation, as it approaches infinity, is going to go towards 2. Cool. All right. That's all. See you in the next lesson.